I was spending a little time on the internet downloading some pictures to help with our lesson. I did school photography some years back, and there's your typical class picture, and there is your typical wallet picture. Okay, we're going to get on now to example 7, where we have the price of admission for a concert, and there I have a little bit of a concert hall there, was $9 for adults and $4 for children. Together, 1,770 tickets were sold, and the resulting revenue was 14,680. How many adults and how many children attended the concert? So the first thing we're going to do is to pick out a letter that will stand for what we're doing. And how about A for adult tickets, C for children's tickets? This is the number of adult tickets, number of children's tickets, and together they were 1,770. Now, what was the cost of an adult ticket? Well, $9. So we get 9A. And children's tickets, $4. We get 4A. And that equals $14,680. So our two equations then, as we move this up, right here. So what method might we use? Well, if we solve for the letter A, just transpose the C. We've used this method before. This is what A is. So we now write our next equation. 9 times A, which is 1770 minus C plus 4C equals 14,680. All right, let's work this. So 9 times this is this. 9 times a negative C, negative 9C. We're going to group like terms. Here we get a negative 5C. We're going to subtract this from both sides. So we then get this in blue. Then we're going to divide both sides by a negative 5. And we get C equals 250, which is what we have. Now, if we subtract 250 from 1770, the difference is 1520. That would be your adults. Okay, let's take a look at the next one. We have a trip that Mike makes in 40 hours. Joe can make the same trip in 30 hours. Joe was traveling 6 miles per hour faster. How many kilometers was the trip? Okay. Well, we're going to use basically the formula distance equals rate times time. So this equals distance. So in a sense, we're going to have rate times time equals rate times time. So our first rate is 40 hours times an unknown rate. The other fella does the same distance in 30 hours, but his rate is the same as this, plus 6 kilometers an hour faster. So there's our first equation, and we're only using one variable for this. So when I get rid of parentheses here, I get 30r plus 180. I'm going to subtract 30r from both sides. I get 10r equals 180. R equals 18. So if R equals 18, which is the rate times 40 hours makes the trip 720 kilometers long, which is what we have. So in number 9 now, we have a hiking club that hiked to a state park at 4 miles per hour. They got a ride back to town in a truck that went 20 miles per hour. If the total trip took 18 hours, how far was it from the park? Okay, so here they're walking at a rate of 4 miles per hour for a certain amount of time. Then going back, they're at a rate of 20 miles per hour at a certain amount of time. Now, we know that the first amount of time, A, plus the second amount of time, B, was 18 hours. And we know that this distance, 4A, equals 20B. So there's basically our two equations. A plus B equals 18, and 4A equals 20B. Here, this is distance. Here, this is time. So rate times time equals rate times time. So what do you suggest? Well, I suggest solving for A. A is going to equal 18 minus B, which we're going to put right there. So 4 times A, which is 18 minus B, equals 20B. So we use the distributive principle, get 72 minus 4B, transpose the negative 4B to this side, get 24B, divide both sides by 24, B equals 3. But they don't want to know the amount of time, they want to know the distance. So then we take 20 times B, which is time, and that gives you 60 miles. So these folks walked 60 miles. Wow, that's a long trip. No wonder they wanted to ride back to town. Okay, here we have Lucy swimming down here. And I'll set this one up for you too. So when Lucy swims with the current, that is downstream, the current moves her along, and then her own swimming, of course, moves her more quickly. Now when she goes upstream, she's going to fight the current. She only has her own rate to help her, but still the current is pushing back at her. So they're saying that her rate basically, and she's going to swim 6 hours both time. So again, we have distance equals times the rate. So time times the rate will equal distance. But we have two sets of data. Well, let's say her rate going downstream with the current will be R, then adding the speed of the current. So R plus C is her rate going downstream. So what do you think her rate going upstream will be? R minus C. So what we're going to do is over here, we're going to put R plus C, and with the current, she goes 18 miles per hour, or kilometers. And then here, rate minus the current, and here this is 6 hours for both. And this is going to be 14. So that's where I got these formulas for. So what do you do with them? Well, you have to clear parentheses, so we get 6R plus 6C equals 18, and 6R minus 6C equals 14. So we're going to use the technique of elimination. Here we get 12R equals 32. So her rate then will be 32 divided by 12, which is 2 8/12, or 2 2/3, which is what we have for Lucy's rate. And the rate of the current, if you put your 2 2/3 in there, will be 1/3. Okay? So if this is 2 2/3 plus 1/3, that's actually going to add up to 3. So 6 times 3 is 18. That's what we had. Okay. Now, both these are similar. So as we do them, we'll show you the similarity. A druggist has various solutions, 10% iodine and a 50% iodine. How much of each solution should the druggist use to get 100 milliliters of a 20%? Well, here, the first thing we do is identify our solutions. We're going to call this one A, and we'll call the 50% B. So eventually he's going to end up with 100. So our first equation is A plus B equals 100. Now, what's the strength of A? Well, we said it was 10%. So 10% of A, and we don't know that. That's where algebra is so wonderful. And what's the other solution? 50%. Now that's going to give us a mixture that we're looking for, which is 20% right there, of 100. You see, you're setting up your parameters of what the letters stand for, and then we're using algebraic technique to solve it. So again, we could use substitution, or we could use elimination. Let's set it up. We've used substitution a number of times, so let's use elimination. A plus B equals 100. And now we're going to have 10A plus 50B equals, we just can multiply that. 2 times 100 is 2,000. So I need 3 zeros here. Okay, now nothing cancels out. But notice if we use the technique of multiplying this first equation by a negative 10, each term by a negative 10, this A term becomes a negative 10A, and these will cancel. So let's write that out. So multiplying every term by negative 10, I get this line. I've modified my first equation. I just copy my second equation. I now put a line underneath them. And now I do my addition. These cancel out. This gives me 40B equals 1,000. I divide both sides by 40. I get 25. Now my B, you recall, was the 50% solution. So of my 50%, I need 25 milliliters. Well, I'm going to end up with 100, so the other amount is 75%. So again, we used a different method. It works either way. This is the elimination method that I want to show you. All right, let's go on to the second one. This is going to be very similar. Chemist has one 20%. We'll call that A. Alcohol. The other is 60%. We'll call that B. And again, he wants to get 100 milliliters. So A plus B equals 100. Now what's the concentration of A? Well, we said it was 20%. Plus our B was 60%. And we wanted to get a 52% solution. There's our two equations. Now we want to get rid of our decimals to make it a little easier for us. And we're going to solve for A, this one. A equals 100 minus B. So let's set that up. So we get 20 times A, but we're saying A is 100 minus B plus 60B equals this. So here we get 2,000 minus 20B plus 60B equals 5,200. Group our B's together, we get 40B. Now we're going to subtract 2,000 from both sides. This will give us 3,200 over here. We're going to now divide both sides by 40. And here that's that, and that goes into there 80 times. Ooh. So our B is 80. 80 right there of the 60%. And of 100, then there's 20 for the other. So we did one by elimination, one by substitution. So these next two are very similar. They both deal with perimeter of a rectangle. One is 54 inches, and the other is 58. And we're, instead of using length and width, we're using base and height, which is like length and width. So there's our basic perimeter formula. 2h plus 2b equals 54, and the same for down here. And then the only difference is, what is the other equation? It says 2 times the height is 3 more than the base. Well, 2 times the height is 3 more than the base. Just translate it into algebra. And for this one, the base is 5 more than 3 times the height. The base is 5 more than 3 times the height. So let me work one for you. So for this one, we have to solve for the letter B. So what I'm going to do is take the 3, transpose it to the other side. So there now is our value of B. So we're going to do 2h plus 2 times. Now we said our value for B was 2h minus 3, right there. And that we said equals 54. So we get 2h plus 4h minus 6 equals 54. Group our like terms. 6h, transpose that, becomes a positive 6 on this side, gives me a 60. Divide both sides by 6, h equals 10. And if we use this formula here, if h is 10, we go 2 times 10 minus 3 equals b. Well, this is 20 minus 3 is 17. And the other one is done exactly the same way. So let's keep this about 22 minutes, and we'll do one more section in another video.